Hey guys, so today we're going to be talking about volume of pyramids and cones. We already know what a pyramid is, we've already seen what a cone is, and we're also going to be kind of looking at composite solids. So when we're talking about composite solids, that's when you have one or two more solids that are combined. So it could either be a solid that's superimposed on top of another solid, or it can be like carved out of a different solid. So it's just when you have two or more, polyhedrons, or two or more, not necessarily polyhedrons, but two or more figures involved. So let's look at, oops, excuse me, I don't know what happened there. Okay, so volume of a pyramid. For a pyramid, the volume will always be 1/3 base, so that's the area of the base, times the height. Okay? For a cone, it's still going to be the same thing. It's still going to be volume equals 1/3 base times height, where B is the area of the base. But the only thing is that because this is a cone, we know that the base of a cone is a circle, which is why they said pi r squared. So let's get right into this. Let's look at this first example. So it says, find the volume of the pyramid. So again, we know that the volume of a pyramid is going to be 1/3 base times height. So I know that my base is a triangle. So because it's a triangle, I'm going to use 1/2 base times height, and then times the height of my entire figure, which is 9. So if I look at that, that's a volume equals 1/3, and then times 1/2. We know that the base of the triangle is 6, so times 6, and then we're given the height, and that's 4, and then times 9. So when you solve this, you end up with 36 centimeters cubed. All right, for this next one, let's kind of do the same thing here. So we know that volume equals 1/3 base times height, where the base is the area of the base, which in this case, the base is a square. It doesn't look like a square, but it is. So volume equals 1/3 times the base. We know that the base of a square is just going to be the side length squared. So 6 times 6, which is just 36. And then times my height, which is 8. So when you plug that into the calculator, you end up with your volume is 96 centimeters cubed. So for this portion, we're asked to find the volume of a cone. So again, for the volume of a cone, we know it's still going to be 1/3 base, what am I doing here? Base times the height. In this case, since the base is a circle, I know that the area of a circle is going to be pi r squared, and then times the height of this entire figure, which is 4, so times 4. So I'm just going to go ahead and plug in everything that I know. I know that my radius is 3. 3 squared is just 9, so I'm going to do pi times 9, and then times 4. I'm going to go ahead and plug that into the calculator. So I end up with volume equals 12 pi, which is approximately 37.7 centimeters cubed. All right, looking at question 4. It says that a right cone has a radius of 5 feet and a slant height of 13 feet. So I'm going to go ahead and draw this out. Okay, so we're given that the slant height is 13 feet, and we're also given that the radius is 5 feet. Now, in order to find the volume of a cone, we need to know two things. We need to know 1/3 times, we need to know the base, and we need to know the height. They give us a slant height, that's not the height. In order to do that, you can form a 90-degree triangle. 90-degree triangle. So then from here, you can just use the Pythagorean theorem. So I know that 13 is my hypotenuse. So I would do, and then this is my height. So I'm going to do height squared plus 5 squared equals 13 squared. And then I'm just going to solve for h for my height. So when you end up doing this, you get h is the square root of 13 squared minus 5 squared. And then when you plug that into the calculator, you get that h is 12. So I have my height now, and I can figure out my base. So I'm going to do volume equals 1/3 times my base, which is pi r squared, right? 5 squared is just 25, so 25 pi. And then times the height, which I just found, is 12. So when you put this into the calculator, you end up with approximately, I guess I should use approximately signs, 314.16, and that is feet. That's cubic feet. Okay, moving on. So for this one, it says a pyramid with a square base has a volume of 128 cubic inches and a height of 6 inches. Find the side length of the square base. So we know that this is a pyramid with a square base, right? Which means that all the sides of the base are congruent, right? So we're given that the volume is 128, right? 128 cubic inches, and then I know that the volume of a pyramid is always going to be 1/3 base times height, big B. So the 1/3 area of the base times the height. So I know that my volume is 128, and then I know that my base is going to be s times s. So it's going to be s squared, right? So the area of a square is always going to be side length squared. So I'm going to do s squared, and then times my height, which they give us that the height is 6. So then from here, I'm going to multiply, so 1/3 times 6 is going to give us 2. So I have 2s squared. I'm going to divide both sides by 2. So then I have s squared equals 64. I'm going to take the square root of both sides to get rid of that squared. I end up with s is 8 inches, which means that each of the side lengths are 8 inches. For this next one, it says that a pyramid with a rectangular base has a volume of 6 cubic feet. The length of the rectangular base is 3 feet, and the width of the base is 1.5 feet. We're finding the height of the pyramid. So again, I'm just going to plug everything in. I know that volume equals 1/3 base times height. So we know that this pyramid has a rectangular base, so we know that the base is going to be length times width. So I'll just plug in everything I know. I know that it's 6 cubic feet, that's the volume, and I know that my base is 3 times 1.5, and then I don't know my height, so I'm going to keep that as h. And then from here, I'll just solve for h. So when you do that, the 1/3 and the 3 cancel, so you're left with 6 equals 1.5h. I'm going to divide both sides by 1.5. These cancel, so then I'm left with h equals 4 inches. All right, moving on to this next one. A right cone has a volume of 528 cubic meters and a diameter of 12 meters. We're finding the height. So once again, volume equals 1/3 base times height. Since this is a cone, I know that my base is actually going to be pi r squared, and then times the height. Now I can figure out what my radius is, because my diameter is 12, so the radius would be 6. So this would be, and we know the volume, so I can just go ahead and plug that in. So I have 528 equals 1/3 times pi times 6 squared, and then times h. So I'm going to go ahead and simplify this. So I end up with 528 equals, when you simplify this side, you end up with 12 pi h. I'm going to divide both sides by 12 pi. And so then you get h is approximately 14 inches. For this next one, it says find the volume of the composite solid. So basically you've got two cones, right? You've got one cone superimposed on another cone, right? And in order to do this, you're actually going to find the volume of each of these and you're going to add them together, right? So I'm going to go ahead and do this. Now they share the same base, so then I know that the base for each of these, the area of the base for each of those cones is going to be the same. The only difference is their heights. So each of these cones will be a little bit different. So I'm going to do the first one. So for my first one, it's going to be 1/3 times the base, which in this case, the base of a cone is going to be pi r squared. So I know that the radius is 7, so it's going to be 7 squared, which is 49. So I have 49 pi. And then times the height, I'm going to do the top cone first. So the height of the top cone is 6. So I'll do 6. Okay? So this right here is the volume of my first cone. Now I would have to add that to the volume of my second cone. So again, it's going to be 1/3 times the base, which we have already found that the base is going to be 49 pi, since they share that same base, right? And then times the height of the bottom cone. The height of the bottom cone is 10. So this is what I'll be putting in the calculator. I'm adding the two volumes. So you have this first one simplifies to 98 pi. This second one simplifies to 490 pi over 3. When I combine the two, I get that the volume of this solid is approximately 821 inches cubed.